The next property we are going to look at for your ionic compounds is electrical conductivity. So ionic compounds are good conductors of electricity, but only in molten and aqueous state. Okay, in solid state, they are non-conductors. They cannot conduct electricity. Okay, they are non-conductors. Okay, if you recall, to conduct electricity, we need to have what we call the mobile charge carriers. So mobile means they are free to move. They can move around. And then the charge carriers means there's a positive and negative charge. So anything that's free with plus or minus can act as mobile charge carriers to conduct electricity. Okay, so what's going to happen in solid state? Yeah, the ions are held in fixed position in a giant lattice structure by strong ESFOA between the ions, and they are unable to move freely, so they cannot conduct electricity. If you remember solid state in kinetic particle theory, solid state, the atoms or the particles are being arranged vibrating about fixed position. So they are fixed and they are vibrating. They are not mobile, they are not free, so they cannot conduct electricity. Okay, they are unable to move freely and cannot conduct electricity. Why are they unable to move? Because they have strong ESFOA between the ions. Okay, and in molten or aqueous state, okay, first of all, a lot of students are confused between molten and aqueous. Okay, molten is just another word for liquid. So the states that we are going to learn: solid, liquid, gas, and then aqueous. Okay, so sodium chloride solid is the solid salt in the kitchen. Sodium chloride liquid is when I heat the solid salt in the kitchen until it melts and it starts to flow. That's the liquid state, and that is molten or liquid state. Okay, and then if I heat this liquid until it turns into gas, and it boils and it turns into gas, then that's your sodium chloride gas. Sodium chloride aqueous. Aqueous means dissolve in water. Okay, so sodium chloride aqueous is a mixture. It's a mixture of water and salt dissolved inside. Okay, so what happens is when you have a solid salt particles, the arrangement will look like this. Okay, the green ones is your minus, the gray ones is your plus. Okay, the gray ones is your cations, Na plus, the green ones are the Cl minus. In solid, they are vibrating fixed position held by strong ESFOA, so they cannot move. They are not mobile. But when I dissolve it in water in this picture over here, okay, the ions will separate. If I draw a picture over here, if I put the NaCl in water, it becomes NaCl aqueous. The NaCl will split into Na plus ions and Cl minus ions with water around them. Okay, so once it splits into this, we say that the ions dissociate and then they are free to move, so they can conduct electricity. Okay, remember, ionic compounds cannot conduct electricity in solid state, but they can conduct electricity in aqueous state or molten state. Okay, molten state, why is it so? It's because the ions are going to be sliding in layers. So when you're sliding, it's quite free. They can act as charge carriers to conduct electricity.